Yeah, thank you. Yeah, my name is Henrik Thorén, and I work for a company. It's called Ramboll. We are 13,000 strong globally. We have a base in Denmark. We're a Danish company originally, but we also have companies in Sweden, Norway, Finland, and so on. And also a couple of offices globally. And I'm in the Ramboll water sector, where we are around 500 globally. I'm Swedish by origin, but I work in Copenhagen, so I cross the border every day. So I feel that international feeling as well. Yeah, so my background is actually not JS at all. I'm a civil engineer within water, basically. So I do hydraulic modeling, both hydrological and hydraulic modeling, mainly for sewer system in cities, urban cities, like the size of downtown Vancouver. We've done a lot of projects in Copenhagen. For that, we use Mike Urban, and which is basically a 1D model that simulates these sewer systems. And with Mike Urban, you can also couple a 2D model. So when you have surcharge from the sewer system where the water goes up in the terrain, you could put the water into the 2D model instead. You can simulate flooding, basically. Yeah, so this is Mike Urban. For those of you that know ArcMap, it's quite familiar. It's built upon ArcMap. It looks like ArcMap, but it's unfortunately some of the good features are removed. But they've put a layer on top of it so you can actually access the different tools that you need for hydraulic modeling. It's developed by DHI in Denmark, which is the Danish Hydrological Institute. They're also consultants, but they're half-state company. And this model, it saves the data in an Access database. Yeah, so the problem that we have is that we normally take a start in a status model, as we call it. So we import all the piping information from the pipe database from the municipalities. We found out where there are problems, and then we want to mimic some different scenarios in order to cope or to solve the problems that they have. It could be many scenarios, typically 2 or 3 or something. And when we've been working on these projects for a couple of months, we don't actually know in detail what we've done in all steps. So we needed a tool to automatically tell us what have you done. It could be intentionally, but could also be something that you didn't want to change. So it's also possibly a documentation tool, but also possibly a check tool that you haven't done something that you didn't want. So the way that I solved it, oh, sorry. Yeah, I'm looking at one slide ahead here, sorry. I wanted to utilize the database comparison tools that are in FME to solve this. I wanted to write it out to Excel, so we have that as documentation together with our models. And so I saw that we could actually use the data-driven pages to make maps out of all of these changes. So we have both the hard-coded Excel data, so you can go in and really look into the details, but also get a rough overview of where these places are, because if you look at the node name or manhole name, you don't really know where it's located, but if you have a map on site, you could probably figure out if it's something you wanted to change or if it's something that's changed because of a mistake. So how many know data-driven pages and what it can do? Okay. So for those of you that don't know, it's basically a tool within ArcMap where you can generate maps automatically. If you have one view, so you can let it switch places where you make the map automatically. So my FME solution was basically I take the original attribute and compare that to an updated one, make a comparison, write that out to Excel and to a MDB file. And from that MVB file, I figure out where we've made all of these updates. I try to aggregate them, so changes that have been made close to each other is viewed in one map instead of maybe 20 maps showing the same thing. I feed this into data-driven pages and let that generate maps, basically. The problem I had when I started is that I'm not only interested in the new value and the database, I also want to know what was the old one, so we can figure out if it was something that was intentional. So I needed to solve that problem as well. And I'd call this the world-class workspace. I don't think so. It's not. It's very repetitive. I basically have developed one custom transformer and used that repetitively. I didn't put that much time into it. Maybe I could have automated it a bit better, but it works. So basically, it's built up like this. That on the different lines, that's the different tables that I compare, and then on the different columns, that's the different attributes that I'm comparing. So I don't compare all the attributes, just the selected ones and the ones that I find important. That is important for the model result, basically. So if you look into one of these custom transformers, I utilized the update detector, which is built upon another update detector, I think. I think it's Dimitri that made it. And here I actually got to know the bulk attribute renamer, because I wanted, as I said, I want to know the before and after. So in this custom transformer, you select which attribute you want to analyze, and then with the bulk renamer, I just make a copy of that one, just call it old instead. I think that's this one. So I just add a string afterwards and say that it's the same string name, just underscore old. Yeah, so I use the update detector, but that's mainly, the focus of that transformer is that you should figure out what's updated and then go in and update a existing database. But in my case, I just have an empty database. So I don't want, when it's coming out of this updated one and deleted and unchanged, or yeah, maybe just these two here, they actually get a value in this here FME database operation that's set to be update, deleted, and so on. But I want all of them to be inserted because I want to insert them into an empty database. So that's something I had to do. And when you write to a database, you also have to tell which key to be updated. I didn't find that working, I think, in this. It was a couple of years ago I did it. Instead, I just took the FME underscore where and said it should be the object ID. I don't know if it was a bug or something, but it just worked when I did this, so just stick to it. Yeah, so this is an example of the output. So I've highlighted one where I've updated the diameter of, I guess it's a node in this, or manhole in this case. And then you can see over here the before and after value. So actually the one on the left is the after one, and then the one on the right is, you can see the underscore, so it's underscore old. So you can see that's specifically what's been changed for this node. Yeah, and then, as I said, I want to have a quick overview of this. So I wanted to use the data-driven pages. So I made a quick template in ArcMap, which is just a MXD file, sets all of the layers up that I wanted, highlighted the ones that were inserted with green, updated with orange, and red for the ones that's deleted, basically. So we have an example here. I think this node has actually been deleted 100%, so that it lost its object IDs. That's why it's saying that it's both inserted and deleted. And here it's some, I think it's the name of the manhole's been changed, and then some, actually some catchments that's been deleted and some that's been added here. So it could put more time into layout, but that was a quick and dirty solution. So the way that you do this is with Python actually. So how many know Python has used a Python caller? Okay, it's like 25% maybe. Yeah, I mean, you can use Python caller when you actually want to do something that's a bit extraordinary. Like in this case, you want to go out to another software and utilize a tool. So you have to do a bit of a programming to get this to work. So automatically, when you open a Python caller, you will get, I think it's the FME and FME objects. It's imported by default, but I needed to add the time and the ArcPy library. I think ArcPy is installed with just installing ArcMap, but I'm not sure. Yeah, so I start with reading in where the map is, the MXD file, where I want it to be saved. That's set as parameters in the workspace. I tell it, or I read in actually the MXD file over here. And then because I recently found these new objects that have been updated and made a boundary box around them, I actually need to go into the MXD file and let it refresh, so it refreshes, so it looks at these different locations that I've just found. So I do a refresh, and then I write something to the logger. And then after the refresh, it knows how many pages do I need to make. So I set a for loop from 1 to the maximum number of pages, and I figure out the page number and set that as a variable. And it's actually this line that makes the whole magic, where I export it to PNG. There's, I think it's JPEG or some other ones you can do. I just chose to use JPEG. Oh, sorry, PNG. And then I make a string name, a resolution, and color. So it's not a high resolution image, it's just a small one. I just want an overview. And then I found after testing this out that it's not waiting for the image actually to be exported. So sometimes you only get half the image processed. And the way to solve that was to let it sleep for 2 seconds so it had the time to export the picture. So that's something I found with trial and error, basically. Yeah, so this is how it looks like in the output folder. I have all of these maps, and here you can see the MDB, comparison MDB, and yeah, I also, just because it's easier in FME, printed it out as as shape files as well. And you can do any format. Yeah, so basically to remember, I think I was really happy that I found this bulk renamer. I mean, there's a lot of tools in FME, and you don't know all of them. But I think it's important that you stay curious and always look through what there are. You never know when you need to use it actually. I sometimes just tend to go up and all the way down and figure out if there's any new transformers, because not all of them are actually published when you publish a new version of FME. And sometimes it could be, I mean, they publish a transformer today, but you don't have a project until 5 years where you actually need it, so you need to refresh yourself. So stay curious about both old and new transformers. And yeah, remember yourself that you can use Python to use other types of tools. This was one example, going to use the data-driven pages. But yeah, just talking about ArcGIS, they have very powerful raster analysis tools. So you can also utilize those from Python quite simply. I mean, it's just to tell it the input file, which tool to use, and then the output. It's basically just 2 lines to apply a tool, and it's very well documented. If you know that the tool in ArcGIS, you just search for it, and in the documentation in the bottom it says an example of how you should implement this as Python, and just copy and paste that. Very simple. So. That was it. Thank you.
Okay, does anyone have any questions for Henrik? All right, just hang on, I'll bring the mic back.
Did you consider having a from date and to date and keeping each object that was changed in a historical log table?
I mean, the normal way you work with the database, that's the logic that you do. The thing that, how we handle it when we working with models, we actually take copies of the database. We take the original one, take a copy of that one, work on that one for a specific scenario. So it's actually two separated databases. So, I mean, ideally, the program should be able to handle it, but Mike Urban is not that advanced, unfortunately. So we keep it as two separate ones.
All right, anybody else? Before we come to a close? I have one question. How long have you been using Python?
I don't know, maybe on and off 4 or 5 years or something. I'm using FME for around 7, 8, not 8, I think.
You like using Python? You use it quite a bit? It's a great language. Like, I'm bringing it up because it's one of the things he talked about there. There are times when FME doesn't have a transformer for it, and Python just expands what you can do. He used examples here, bringing some Arc objects into his workflow like that, but you can use Python to do a whole bunch of other things inside of FME with the Python caller. So yeah.
I mean, I would say that FME is good when you want something to happen in a workflow, but if you want to iterate things, that's something where like it did here in the for loop, that's very powerful with using Python.
Yep.
And it doesn't demand that much code, but the downside is that it is a bit, when you write it as a Python caller, it's a bit hidden in the system. And yeah, we all been talking about this, how to document and document changes. It's not ideal to go to Python, but sometimes you basically have to. And also those, as I said, raster analysis tools. If you want to find a catchment area based on a DTM, for example, I would hope that sometime that would be included in FME, but right now it isn't. Right. But it's very easy to just go out and ask ArcGIS, make this for me. And it's much easier now when you have the feature writer or feature reader, because then you can write it down to a temporary folder, run the analysis, and then read it back in, and then just delete the files that are in it. So
yeah, that's great. Anybody else? Oh, Renato, I'll.
Did you have to open, did the Python caller open ArcMap to run data-driven pages?
No, I mean, I made this template. I made this template, and I put basically all the tables that I need from that MDB database. I set that up for one scenario, basically, and then I just reuse the same MXD all and over. But I mean, as soon as I've made this one, I don't have to go back. I don't have to edit it. That's as this here. The only thing I need to do is to refresh, so it updates the amount of pages that it should generate. That's the only thing I need to actually do.
Yeah, so that's every feature is coming in here, and you're creating a new little map, right?
Yeah. It makes a bounding box, and then it goes from each box and makes a map. So it actually makes them in different zoom levels automatically. You can tell it how much of this bounding box it should cover. I mean, you could use a buffer and adapt how much extra it takes in the picture, but you can also tell that in the data-driven pages, like, okay, give me 100 pixels extra or 10% extra or something like that.
Yeah. Okay. Oh, we have one more question here. I'll come over with the mic. You got a big voice, but try to.
How did you configure the change detector to detect change? Is it based on a unique ID or a timestamp or both?
Yeah. There is an object ID in the database that's kept the same. So it's only looking at that. So that's where you saw in this example that actually the one that's red and green is, I think, basically the same manhole. The only thing is that the user have deleted the object and entered a new one in the same location, then it gets a new object ID. Otherwise it should be just said updated.
So is it reading the entire data set looking for changes, or is it only
Yeah.
considering those that changed?
No, it's reading all of them. Yeah, because
Is there a way to configure it to only consider those that have changed rather than reading the entire data set?
maybe, but it also relates to what I said before, that the way we work with it is that we have two different copies. It's not ideal. You would, in a perfect JS world, you would have all the records. You can just go back in like a scenario manager. The problem we've had with that is when you jump between scenarios, it sometimes loses some information, and that's, I mean, then we rather do it manually, basically, and not have that thread. But I mean, we're talking about, I mean, a large model is 10,000 nodes or objects, so it's not a huge database. It's yeah.
Thanks.
Okay, I think that's good. So, thank Henrik.
Thank you.